This video deals with the first test of HP-PMZ done in the public utility CCAM. In particular, it shows the results of the test with a Bermad pressure regulating valve. Let's start with the HP-PMZ features. HP-PMZ is a software for the control of a PRV or a pumping station with the objective of managing efficiently the pressure in a pressure management zone. It is independent from the manufacturer of the PRV or of the pump. It is totally configurable via the remote SCADA of the customer or locally with a web server HMI. It runs on the Lacroix Sofrel S4W RTUs. It implements the most popular control algorithms of pressure control, time of day, flow modulation, virtual critical point. It includes also a multi-point control suitable for managing fragile networks, for instance, old towns. And special algorithms can also be developed for particular PMZ. This picture shows the test ground in CCAM. The test ground allows the complete test of a pressure control system, including the control of a critical point. Let's see the control architecture. In our test bed, we have two Sofrel pressure sensors for the inlet PM and the outlet PV pressure, a Voltman counter with a digital census interface, generating pulses for measuring the water flow, Q. Two up and down solenoids for increasing or decreasing PV with pulse commands, plus an emergency solenoid to bring the PRV to a standard set point in case of alarms, not shown in the picture. Finally, a data logger at critical point for logging the pressure trends there. This is the site where we tested the HP-PMZ. We have here a Bermad PRV equipped with two solenoids up and down, which allow to modulate up and down the outlet pressure measured by this pressure. We have also a third solenoid here, which is used for setting the PRV in a safe situation in case of alarms. Finally, we have a Voltman counter equipped with a census interface which sends us pulses and allows to measure the flow. Let's start with time-based control. HP-PMZ has a time of day algorithm. With this algorithm, the outlet pressure PV is set along the day based on a timetable. So we have PV equal to a function of time. The changes are always executed by ramps in order to have a smooth dynamic and to avoid water hammers. The timetable is different based on the type of day. For instance, it's different in a working day or in a holiday. In the video, we simply evolve directly from 2.0 bar, 2.3 bar, 2.5 bar. We have set the set point at 2 bar. The system gets close to the set point quite quickly initially, and now it's moving quite slowly in order to reach it definitely. The indicator here is not so precise as our sensor, but anyway, in this moment we are in deadband and the set point was reached. Francesco, please set the set point to 2.3 bar. Okay. We started to move and we reached very quickly the set point of 2.3. Okay, now Francesco, please set point 2.5. The movement is not immediate. Okay, it started, and now we have reached the new 2.5 set point. The system is again in deadband. Flow-based controls. HP-PMZ has also two flow-based algorithms. The first is the flow modulation. In this case, we have PV equal to a function of Q, the flow of water. Once again, the algorithm setup can be differentiated by date type. The second is the virtual critical point. In this case, we have PR, the pressure at critical point, equal to a function of time, and consequently, PV is equal to PR plus a function of Q sufficient to compensate for the drop of pressure from the outlet of the PRV up to the critical point. As usual, the algorithm setup can be differentiated by date type. In the following video, we see the evolution of the critical point pressure, PR, from 2.0 bar to 2.5 bar with a ramp lasting 10 minutes. Now, we want to make a test of the virtual critical point. The circuit is working in this moment at 2 liters per second, which determines the drop between here and the critical point where we want to execute the regulation. The test that we want to do is a test where at the critical point, not here, but at the critical point, we will have a pressure starting at 2 bar and going to 2.5 bar. Of course, here we will have a different pressure because the regulation has to compensate the pressure drop due to the current flow of water. So now we are starting. We have here 2.7 bar, which corresponds to a value of pressure of 2 bar at the critical point. Okay, now the ramp is about to start. The measure in the indicator, as usual, is not so precise, but the ramp is starting, and we have pulses on the solenoid, in particular on the up solenoid. The pressure is slowly increasing. Okay. Now the ramp is really started. We are approaching the 3 bar pressure here at the exit of the PRV. But the ramp is continuing to go up, and in 10 minutes we have to reach at the virtual critical point the pressure of 2.5, which correspond more or less to something like 3.2 bar here at the exit of the PRV. So we are very close to the target. The 10 minutes are about to finish, and the ramp is done. Special controls. HP-PMZ has also other algorithms. A multi-point control for fragile water networks, for instance for old towns. Furthermore, We are in condition to develop special algorithms for special cases, PMZs with more than one water supply source, PMZs where the critical point is changing during the day, and many others. Let's now see the test team. The test team in CAM included specialists from CAM, which is the company owning the test ground, Prometeo, Hyper STP, which is an hydraulic engineering company, and Bermad, Italy, and Spain. I thank you for your attention. If you want more information on HP-PMZ, feel free to contact me at the following email: